Alright, I'm going to run through how I have this set up, and then we'll go ahead and step through the first few steps and then let it run. What happens is the bar, the sub spindle opens and synchronizes with the main spindle. Then the sub spindle will close, and it will then start cutting the threads. So I have this nut on here, and it's a stainless steel nut, but it's got a little bit of magnetism, so it'll stay with this magnet to the sub spindle. I've got that on there so that I can run the nut up when I'm done, make sure all the threads are good before taking it out. This is the specific nut that they want us to fit onto it, so we're going ahead and making it to fit on this. Alright, so the first thing we do, we're going to go ahead and single step through this. Alright, just going to run some code to get the machine set up, a few lines there. Sub spindle open, synchronize to the main spindle. Alright, it's going to close the sub spindle. Okay, then what it's going to do is it's going to back up about 10 thou up against the main spindle, giving it some pressure. Alright, just did it there. I'm going to turn my rapids down and we're going to go ahead and get started. Oh, actually, next thing I need to do is put some oil on this thing. I'm going to run it with the door open so I can actually get some video of it, and so we're going to put some cutting oil on it. Alright, single block off. Alright, here we go. Speed it up a little bit. And that's pretty much it.
Okay, so the reason I did it the way I was doing it here is because you can't synchronize the spindles without opening one. I can't open the main spindle because then I'll lose my concentricity on the center. And so I had to open the sub spindle in order to get it to synchronize. So I ran all the parts, but on the very last part, the insert had chipped, so the nut wouldn't run up on it. So there's no way doing it this way to keep the part in the same orientation and resynchronize the spindle. So I had to rewrite the program into a much better way of doing it. And of course I don't have video of that because it was the very last part and I had already moved the camera to the other machine, thought I had all the video I needed. But basically what it does is I lie to the machine and tell it that it's clamping and doing an ID clamp. So when the main spindle is closed, it thinks it's open because it actually thinks it's supposed to be trying to ID clamp. So then I can synchronize the spindle and not lose my orientation, with the part in the sub spindle, and I can continue threading on where I left off. So basically what that code does, instead of opening the sub spindle, it just pulls the sub spindle out about 20 thou, synchronizes it, and then brings the sub spindle back up in line and pushes up against the main spindle. And again, that allows me to just continue on threading if the threads aren't deep enough or if there's a problem. I can stop it at any point in time, back it out, run a nut on it, check my threading, do whatever I need to do, and then continue the program off from where it was and not have any thread alignment issues. Also, it's much safer in the fact that I don't have to put the machine into single block mode, hold the bar in there with my hand while the sub spindle's clamping down. I did actually put a delay in there so that, there's plenty of time to get your hand out of there before it clamped, but it's never a good idea to have your hand in the machine when you're running it. So, this is actually a whole lot better way of doing it. And if you want the code, just let me know. I'll post it down below. But basically, I lied to the spindles and made it think that it was unclamped, backed out, reorientated, came back in, and did it that way. It's way better. The cutting oil I'm using here is high sulfur content, so by the time we were done, the shop smelled like fire and brimstone. I may not be a smart man, Jenny, but I know the smell of Hades when I smell it. Several moments later.
Alright, we're on the last pass here. Turn the rapids down to 0 so that when it finishes this pass, it'll keep the machine all synced up.
As my father would say, do as I say, not as I do. Don't put your hands in the machine like this, please. Not a good idea. I almost cut this section out of the video. This is really not safe to do. It's spinning really slow here, but anything can happen. These machines aren't going to stop for anything. Get your finger caught in something, get your glove caught in something. Although I try to wear these rubber gloves because they'll just rip, but anything can happen, and these machines won't stop, so please don't do what I'm doing here, guys.
We'll call that a good part. This is how we're going to load this job up. I've got to stop here. We've got to cut a flat here, and then one 180 degrees here. Tall. I'm going to mark this jaw. This should all be pretty square, but just to kind of try to keep things consistent with the stop here. Alright, so what it's going to do is going to come in and cut this flat here, and then I'm going to rotate this fourth axis, which is run off of Mach, 180 degrees, and then we'll run the same operation to put the other flat on.
I believe we're taking about 125 depth of cut here. I'm just doing an adaptive to clean this area out, and then I come back. I believe I leave like 5 thou and just come and clean that off in the next passes here, just to make it nice and clean. As soon as this operation finishes, the machine goes back to its XY home position, and we rotate the fourth axis 180 degrees so we can get access to the second side and cut the flat. I'll show the mock screen here in a minute of how we actually do the rotation. Here we're just running the exact same operation that we did on the first half of the part. At the end of this operation, I rotate it back to the original orientation. That way I can put my stop in the exact same jaw in the exact same position every time. That's pretty much it for this. We pull the part out. Now I'm going to go ahead and switch over to showing the mock side of things.
Alright, so once we deck the top, we rotate the part by using the 4th axis here. So I'm just going to rotate the A axis by 180 degrees. This is my old mock setup that we used, Mach 3, for that we were using for the PM940. I pulled all the equipment over here because we have a job that uses it's going to use a 4th axis. But since we have it, we're going to go ahead and use it here. Alright, here we go. This isn't normally how we do them. Usually we did it another way where we flip the parts 180 degrees, but we have this in here for another job, so we might as well use it.
Alright guys, that's about it. Here's the finished part. I really enjoyed making this video series. I feel like I might be skipping over things or glossing over some things, so if you could give me your guys' input and let me know what you'd like to see more of, what you'd like to see less of, help me make these videos better for you guys. Thanks for watching.